Okay, let's dive right into this. Welcome to The Explainer. Today, we're unpacking what I can only describe as a brilliant scientific detective story, straight from the bleeding edge of theoretical physics. We're looking at the Atomic Causal Set, or ACS for short, project, and specifically, we're zeroing in on their highly anticipated version 1.5 update. So imagine you're in this situation. What do you do when your physics simulation gives you a totally perfect score? I mean, it's the absolute dream scenario, right? You spend months painstakingly building this crazy complex theoretical framework. You finally run the code and boom, absolute perfection. But as we're going to see today in the wild world of quantum gravity and causal sets, perfection, well, sometimes it's actually a massive red flag. And here it is, that perfect score, 1.0000. Now, this was the delta effective score spat out by the so-called hydrogen test inside the ACS framework. Basically, the researchers were trying to see if the fundamental laws of electrical attraction, that classic Coulomb 1/r potential, would just naturally emerge from the pure geometry of their simulated universe. Hitting exactly 1.0, that is the holy grail. It looked like a massive, groundbreaking success right out of the gate. But as the team rigorously audited their own work, they realized this perfect 1.0000 was actually a flawless illusion.
Section 1, the perfect illusion.
Now, what's really interesting here is this concept of a tautology. In math and logic, a tautology is just a statement or formula that is true by construction. Because it's mathematically locked in from the start, it's completely uninformative scientifically. It's essentially like writing the answer key to a test, taking that exact test, and then patting yourself on the back for getting an A+. You haven't actually learned anything new about nature. And, as it turns out, this is the exact critical flaw the ACS researchers caught hiding in their own code. Let's actually walk through how they tripped the wire here. Step 1, the initial protocol defined the potential, V, as the charge Q divided by the distance dr. Simple enough. But then, step 2, they ran a regression measuring the log of V against the log of that exact same distance. So, step 3, because of how they set the whole thing up in step 1, the math automatically guaranteed a slope of -1. And that gives a perfect delta of exactly 1.0. The hydrogen blocker test was accidentally grading its own backward answer key. It was totally bypassing the actual physics. And the reaction from the team? Swift and brutal. Just look at the audit log. Voided immediately on inspection, not a measurement. The very second they caught this circular dependency, this tautology, they completely trashed their own perfect result. No hesitation. They realized instantly that keeping it around would completely compromise the integrity of the entire endeavor. This moment right here represents a massive paradigm shift for the entire ACS project. It's a fundamental pivot away from the old philosophy, which was really just about running simulations to chase positive results, over to a much stricter new philosophy of rigorous verification and mathematical falsifiability. They realized, hey, getting code to run successfully is totally meaningless if it's not actually testing the physical reality of the causal set. The big takeaway for us here is that failure, especially when it's caught and honestly analyzed, is often the single biggest driver of real scientific progress. Which brings us to section 2, real wins, hard truths. And this brilliantly illustrates the current state of things. This external assessment scorecard perfectly captures the radical transparency of this project. They earned a solid A in internal honesty for explicitly catching and publishing their own mistakes, which actually bumped their overall research program grade up to a B+. But because they voided that hydrogen result and because they currently lack a mechanism for standard model flavor, they proudly and correctly accepted a D in both atomic physics and standard model connections. True science is about accurately mapping your own ignorance, right? But listen, it's not all tough grades. There are genuine, hard-earned numerical victories to highlight here too. Check out this number, 2.027. This represents the macroscopic running spectral dimension. Basically, that's a measurement of the shape and dimensionality of their simulated space. The ACS team successfully showed that this dimension stably flows from 4.0, way down at the microscale, smoothly down to 2.027, and they validated this at n equals 2,000 nodes. That is a massive, mathematically valid structural win for the framework. We're also seeing some really compelling evidence in their thermodynamics. The heat capacity, or Cmax scaling, is fascinating. Going from an N of 1,000 up to 2,000, Cmax jumps from 0.395 to 0.950. That is a 2.4 times scaling. This provides really consistent evidence of a thermodynamic Hagedorn-like transition. If you're not familiar,
Think of it as a fundamental boiling point for the very fabric of the matrix itself. Now, the external review is very careful to point out, and so should we, that this is evidence, not absolute proof. It definitely still needs larger-scale testing for full verification.
So, alongside those big wins, we have the heavily documented structural blockers. Since that tautology was voided, the actual natively produced hydrogen delta is currently sitting at 0.218. That is nowhere near the target of 1.0. On top of that, their S3 leptoquark flavor mechanism is currently off by a staggering 20 orders of magnitude. And that R value of 0.0149, well, right now it's calibrated, meaning it's manually tuned by the team rather than being cleanly predicted from first principles. So make no mistake, serious theoretical hurdles remain entirely open.
Moving on to Section 3, the Green's function protocol.
This right here is priority 0 for the entire research program moving forward. So the crucial point is how this new protocol fundamentally solves that nasty circular dependency we saw earlier. Step 1, they build the graph Laplacian matrix natively on the causal set. Step 2, solve that equation for the Green's function. Then, step 3, and this is key, it's done entirely separately. They compute the coordinate distance from the sprinkling geometry. Sprinkling is basically the process of randomly dropping points into the spacetime to measure it. And finally, step 4, fit the Green's function against that coordinate distance using log-log regression.
When we visually separate this out, it becomes super clear why this actually works. You have the graph topology determining the Green's function on the left, and completely separate from that, the sprinkling embedding determining the coordinate distance on the right. These are fully independent variables now. The scale relationship between them is going to be a genuine, mathematically sound measurement. This new protocol is thoroughly non-tautological.
The stakes for this upcoming experiment? Incredibly high. As the internal logs explicitly state, if a delta of 1.0 emerges here from this new protocol, it's not going to be because they forced it or coded some sneaky loop. It'll be because the manifold geometry actually supports it. A success here would be a genuine, undeniable physical discovery of 1 over R behavior naturally emerging right out of the fundamental graph topology. It's huge.
Let's move to Section 4, from guessing to testing, and see how this all builds together. The independent review highlighted a really crucial takeaway here. They noted, the single most encouraging thing is not any particular number. It is that ACS is starting to behave like a falsifiable research program. And that just reinforces the overarching lesson of this whole explainer, doesn't it? True science isn't just about finding the right answers to make yourself look good. It's about the rigorous, sometimes painful process of falsification. It's about deliberately designing tests that can actually prove you wrong.
The researchers themselves sum up their own evolution beautifully with this really powerful thesis statement. We are no longer guessing, we are testing. They have officially left that era of optimistic, happy path simulations behind. Now, they've entered the demanding, totally unforgiving, but ultimately far more rewarding era of true scientific verification. Which leaves us with the exact provocative prompt the researchers are facing right now at their workstations. Are you ready to begin drafting the Laplacian solver script for the Green's function test? The stage is set, the correct, non-tautological protocol is strictly defined, and the execution is pending. The only question now is, what will the pure, unforced mathematics reveal next? Thank you so much for joining me on this explainer, and I'll catch you next time.